Alright, so today we're going to be taking a deeper look at chemical equations. On Friday we talked about how to balance these equations. Today we're going to talk about how to kind of define them and how do we go about writing them. So we have 5 types of chemical reactions: synthesis, decomposition, single replacement, double replacement, and combustion. So we're going to walk through each of these kind of step by step so that you get a pretty good idea of what you're doing and how to go about doing it. So the first type of reaction we're going to talk about is synthesis. Synthesis is a type of reaction where I put two elements together. So I have A and B, and that yields AB. Remember that when I'm putting two elements together, especially in a binary synthesis reaction, I have to crisscross the charges. So that idea of charges based on the periodic table, +1, +2, +3, plus or minus 4, -3, -2, -1, is going to kind of repeat itself in this unit. So you need to familiarize yourselves with those charges and go back and review those notes if you need to do that. There are two types of synthesis: binary synthesis and metal oxides and water. The first type is a metal plus a nonmetal. Remember, big M is always going to stand for metal, NM is always going to stand for nonmetal. And that forms a metal nonmetal compound, so an ionic compound. The second type of synthesis is going to be the formation of a metal hydroxide. So I have a metal plus water. In writing that metal oxide formula, I'm going to have to crisscross the charges. Plus water, H2O, yields a metal and a hydroxide. So the metal bonded with the OH negative polyatomic ion. So let's do some examples. Let's start with H2 plus Cl2. We remember that H and Cl are both diatomics, which is why they have the two subscripts. So when I take H and bond it with Cl, H's charge is going to be +1, Cl's charge is going to be -1. So if I were to crisscross those charges, I would have H -1, Cl +1. But we remember that we don't write ones, nor do we write charges. So I can go ahead and actually erase those charges. And what I end up with is HCl. If I wanted to take this a step further and name this compound, I would remember that it's a binary acid, two compounds. So it's going to start with hydro. Then is going to come the name of the element, chloric. That ic is the suffix that we add for all acids. And then finally, the word acid, hydrochloric acid. So H2 plus Cl2 yields HCl, or hydrochloric acid. Now, if we think back to what we learned when we talked about balancing equations in class, we need to balance this equation because I have two H's on my reactant side and only one H on my product side. So I can balance that H by putting a 2 in front of HCl, and that in turn will actually balance my entire equation. Alright, Mg plus O2. This is a metal plus a nonmetal. It is not a metal plus an oxide, or metal oxide plus water, because I have no water. So I'm going to take magnesium. Looking at my periodic table, magnesium has a +2 charge. And I'm adding to that oxygen with a -2 charge. When I crisscross those charges, I'm going to have Mg2O2. But remember, if I have the same subscript, I can drop them because they would reduce to 1 and 1. So I end up with MgO. Now, if I look at this, I can see that I have two oxygens on my reactant side because oxygen is diatomic, and only one oxygen on my product side. So in order to balance the oxygen, I need to put a 2 in front of this entire compound. Remember that this 2 is going to distribute to everything inside that compound, which means that now I have two magnesiums on my product side and only one magnesium on my reactant side. So I can add a 2 in front of magnesium in the front, and that is going to balance my equation. Now, as a reminder, if I wanted to name this, it would just be magnesium oxide. And lastly, barium oxide plus water. This is going to be that classic example of a metal oxide plus water. And I know this is a metal oxide because I have barium, which is a metal, and oxygen. So barium oxide and water is going to form barium hydroxide. Barium has a +2 charge, and hydroxide has a -1 charge. And hydroxide is a polyatomic ion, so we need to remember that when we go about balancing and writing our formula, because that's going to affect how we write our formula. So when I crisscross those charges, barium's charge of 2 needs to distribute to the whole of hydroxide. And the only way we can do that is to put hydroxide in parentheses. If I were to name this, it would be barium hydroxide. And in looking at this, BaO plus H2O yields BaOH. It's going to be helpful to write your water as HOH, so that when you go about balancing, you can clearly see that ion represented. So if I count, I have 1 barium on my reactant side, 1 barium on my product side. I have 2 O's, 1, 2 on my reactant side, and 2 O's on my product side. I have 2 H's on my reactant side, I have 2 H's on my product side. So this one is actually balanced. And that is a synthesis. That is how we go about writing synthesis reactions.